I'd like to thank all my co-authors listed here for all their support during this work. Canadian Prairie region is located within the Canadian Prairie provinces, Alberta, Saskatchewan, and Manitoba. It extends from the eastern foothills of the Rocky Mountains to the southeastern Manitoba. It is defined by its vegetation type and also by the moisture deficiency in the region. The region is primarily dry because of its location on the lee of the Rocky Mountains and also for it being far away from major water bodies. The hydroclimate of the region is highly variable, and the region is frequently impacted by significant droughts and floods. Most recently, in 2013, southern part of Alberta was hit by a major flood. This flood was devastating and caused severe economic damage. This flood was devastating and is considered the biggest and costliest natural disaster in Canadian history. Insured losses from this flood were estimated to be approximately 1.7 billion Canadian dollars. Also, the major economic sector in this region is agriculture. Therefore, excess moisture or periodic flooding may either delay the seeding of crops or damage the half-grown crops, in effect reducing the harvest from crops, affecting the economy of the region. The other sector that is affected by floods in this region is transportation sector. The roads and bridges are washed away or overflown by heavy floods, causing disturbance to the road transportation. Therefore, effective planning and design of infrastructure is very much essential in this region. Flood frequency analysis is a technique adopted globally to estimate design flood prior to taking up any infrastructure project. However, there is a major assumption made in this analysis that annual peak flows are independent and identically distributed. But are they identically distributed? Are they really independent? And is the hydroclimate of a region is really stationary? This question has been raised by various researchers across the globe, and few researchers from their regional analysis identified that annual floods are in fact not stationary and are significantly influenced by various large-scale atmosphere-ocean oscillations, including El Niño-Southern Oscillation, PDO, and Multi-decadal Pacific Oscillation, among many others. Hydroclimate of the Prairie region is influenced by various low-frequency atmosphere oscillations. Pacific Decadal Oscillation and El Niño-Southern Oscillation are the major teleconnections among these. Researchers from this region identified that El Niño events and positive phase of PDO produced warmer and drier winters. Therefore, the region received lower stream flows during spring and summer. They also found that La Niña events and negative phase of PDO produced cooler and wetter winters. In effect, the region received relatively higher stream flows during spring and summer. Few other researchers also identified that when ENSO is in phase with PDO, that is when La Niña events were occurring within the negative phase of PDO, the region experienced much cooler and wetter winters. In effect, the region received much higher stream flows during spring and summer. There has been a lot of research done to identify the relations between these teleconnections and annual mean stream flows in this region. However, not much work has been done to check if the annual peaks are influenced by these teleconnections. And in this study, we try to identify those relations. Also, the influence of these teleconnections is not considered during the planning and designing stage of infrastructure, and we make an attempt to showcase the importance of these features. For the analysis, we chose 21 streamflow gauging stations spread across the southwestern corner of the prairies. These rivers originate either from the eastern foothills of the Rocky Mountains or from the Cypress Hills that is located to the east of Rocky Mountains. For the data we used in the analysis is freely available and can be accessed from these data sources. Daily average stream flow, PDO indices, and ENSO indices are the major variables we used in the analysis. Pacific Decadal Oscillation is a major teleconnection affecting the hydroclimate of Western Canada. It is quantified by PDO indices, which is computed based on sea surface temperature anomalies. The influence of this index can be illustrated by plotting the response hydrographs to the PDO events. For example, we chose the strongest negative PDO event and the strongest positive PDO event occurring in 1956 and 1987 and plotted the response hydrographs for all the selected gauging stations. This plot here shows the response of naturally flowing Crow's Nest River in southern Alberta. The blue curve in this plot is the response to the strongest negative PDO event, and the red curve is the response to the strongest positive event. We can clearly see from this plot that there is a huge difference between the magnitude of annual peaks in this river, and this is a preliminary evidence that annual peaks are influenced by these teleconnections in this region. Similar to PDO, El Niño-Southern Oscillation is another teleconnection affecting the hydroclimate of this region. ENSO is defined in various ways. We used multivariate ENSO index to quantify El Niño-Southern Oscillation. The multivariate ENSO index is computed based on various atmospheric and oceanic variables. For the analysis, we extracted the annual peak flow data from the daily average stream flow data sets, and then stratified the annual peak flow data based on the negative and positive phases of PDO as defined by earlier researchers. And we also stratified the peak flow data into El Niño and La Niña floods, and then constructed the flood frequency curves to the stratified peak flow data sets using the Log-Pearson type 3 distribution. And we also constructed confidence intervals based on the methodology described in Bulletin 17B of United States Geological Survey. Finally, to address the issues of spatial correlation and sampling error, we adopted regional index approach. We constructed the confidence intervals for all the streamflow gauging stations after stratifying the peak flow data into the two different phases of PDO. This plot here shows the flood frequency curves for the floods occurring in the South Saskatchewan River as measured near Saskatoon in Canada. The blue curve here represents the Log-Pearson type 3, Log-Pearson fit to the annual floods occurring in the negative phase of PDO, and the red curve represents the Log-Pearson fit to the floods occurring in the positive phase of PDO. And the dotted lines represent the confidence intervals for the respective curves. And the points shown in these plots are the actual flood events occurring in this river. If the confidence intervals are overlap substantially, we can clearly say that the peak flow data is identically distributed, which is not the case in this plot. We can see the frequency curves separate very clearly, and there is no overlap of confidence intervals. In a way, we can say that there is a signal of PDO seen in these frequency curves. Most of the rivers in the Prairie region are regulated for various reasons, and not many naturally flowing rivers are available with the length of data we needed for carrying out the analysis. So we use both regulated and naturally flowing rivers to do the analysis because both the rivers show the signal of PDO. As I said, to address the issues of spatial correlation, we adopted the regional index approach. Regional index is computed by normalizing the stream flow data at each gauging station and then averaging the normalized flows to obtain a regional index series. We then stratified the regional index series based on the phases of PDO and constructed the flood frequency curves as shown here. As the earlier plot, the blue curve represents the floods in negative phase of PDO, and the red curve represents the floods in positive phase of PDO. The frequency curves separate clearly, and there's no overlap of confidence intervals, showing a strong indication that the floods in this region are not identically distributed. And also we can see that the floods in negative phase of PDO have higher magnitude, as can be shown, as can be seen by the blue curve in this plot. To check if the annual floods are similarly influenced by El Niño-Southern Oscillation in this region, we stratified the peak flow data into La Niña and El Niño events and constructed the frequency curves. As we can see, the confidence intervals substantially overlap, and there's no strong evidence that ENSO has an influence on annual floods in this region. But earlier research has found out that hydroclimate of this region is influenced by ENSO when it is modified by phases of PDO. Therefore, we extracted the La Niña floods. We extracted the La Niña floods from the peak flow data set, and then stratified it based on the phases of PDO, and then constructed the flood frequency curves. For example, this plot here is for the La Niña floods in both phases of PDO. The blue curve represents the La Niña floods in the negative phase of PDO, and the red curve represents the La Niña floods in warm phase of PDO, showing a clear separation of frequency curves, saying that higher magnitude floods can be expected in during La Niña events when occurring within the negative phase of PDO. To check if the similar effect can be seen with the El Niño floods, we did the similar analysis and found that at shorter return intervals, the curves separate, but the confidence intervals overlap at higher return periods. So not very strong evidence is seen. To summarize the results, we would like to say the flood risk in southwestern Canadian prairies is significantly influenced or modified by the phases of PDO. And the hydroclimate is not stationary, and the stationary climate assumption in flood frequency analysis is not suitable for this region. And if a stationary assumption is made, the estimated design flood from the flood frequency analysis could be smaller or greater than the actual flood risk. Thank you.
Thank you very much for the talk. We have time for questions. Yes.
So with that in mind, can you tell us what the conditions were prior to the Calgary flood? Was it a PDO?
There was a negative PDO event occurring in 2012, end of 2012, yes.